here is your last video. I just really want you to understand that everything we're doing right now really takes you all the way through the year. We're going to keep coming back to this. And then when you get to 8th grade, the better you understand what I'm teaching you now, the easier it's going to be, because this is really the foundation we kind of reteach in 8th grade. So if you already have that foundation, you're going to do amazing in 8th grade. Okay, so I'm going to kind of drill this. I know. Keep adding to your notes. Keep adding to your notes. So now we're kind of analyzing graphs. It's the same thing, just keep taking it a little step further. Okay, so you can add this to your graph. We are now analyzing, to your graph, to your notes. We're analyzing graphs. And if you want, we're on page 131. Analyzing graphs. So let's do a small review. I know, write it again. If I write, you write. We are in the form y equals kx. K is your constant of proportionality. And then we're going to add something about K. K tells you how steep the graph is. And then what you need to know is the bigger the absolute value, so we're going to write that, the absolute value of K, the steeper the line. And then I'm going to show you what I mean by steep. Okay, so this is not a very steep line. This is more of a steep line. Think of a hill. If you were climbing up this hill, it wouldn't be too bad. But if you were climbing up this hill, whew, you might need some extra breaks, right? Okay, so that's what we mean by steep. So if I had y equals 5x, that's a line. But if I had y equals 6x, that's a steeper line. If I had y equals 4x, that would be more going this way versus like, bam, going up fast. And this one you might need to kind of just memorize for a little bit. And the more we do graphs, the more you're going to see this actually happening, and then it's going to stick in your brain. Okay? You're going to know it because you've graphed enough times. Right now, write it down, have it in your notes, and look at it to remind yourself of kind of like what that rule is. Okay? So pause and write if you need to catch up because I'm about to erase. All right, so we have a situation. Let's read the situation. Relationship between time, which is x, in minutes, and number of miles Damon runs. Okay, so Damon, so we get the graph, and we see Damon has 10. This is time in minutes, and 1, 2, 3, 4. It's not going to be very accurate, but I will mark the point so that you can see what I'm talking about. So 10 and 1, 20 and 2, 30 and 3. Okay. So here's Damon. Okay, so we're going to choose a point on the graph, and we're going to talk about what that means. Now, in the book, they choose 25 and 2.5, and that's okay. But we really like to know what the 1 is. We like to know what everything comes back to for 1, kind of like what we talked about with unit rates. So what I would choose is 10, 1. So 10, 1, you got to really think about what the x means, and of course I didn't label it, and what the y means. So x means time in minutes, and y means distance, and we know this is x, y, just think in alphabetical order. So x is time, so that means 10 minutes. 1 is y, and y is distance in miles, so 1 mile. So in 10 minutes, I go 1 mile. All right? So here's the crazy part. When I'm finding constant of proportionality, is it x's over y's or y's over x's? It's Y's over X's. Okay, Mrs. Wood and I are going to like make shirts so that you never forget that. And my shirt, I'm going to wear it like a big math nerd, and it's going to say Y's over X's, Y's over X's. I think I might have to wear it at your SBAC test because you cannot forget this. It's got to be Y's over X's. So to find the K, am I going to do 10 over 1 or 1 over 10? Think really, really hard about it. I know it feels wrong, but we have to do 1 over 10 because our Y is distance, and this is Y. And our X is 10, and that's minutes. So our K is actually 1 over 10, and our equation is Y equals 1/10 X. I know, and I think a lot of us really wanted it to be 10 over 1, but ask yourself, do we say minutes per mile or do we say miles per minute? We say miles per minute, so that makes it miles per minute, which makes miles in the top. Okay, and I've been trying to tell students that. Try to say it both ways. One way is going to sound right, and the other way is not going to sound right. And the way that sounds right tells you the order you make a fraction in. You write your K in. You do your division to check for proportionality in. It's Y's over X's. And usually you can figure that out by knowing X is time or making a per statement. Miles per minute, not minutes per mile. Okay, so hopefully that makes sense. So that's our constant. So let's look at the reflect part on page 131. What does the point 0, 0 on the graph represent? So what would 0, 0 mean? 0, 0 would be in 0 minutes I went 0 miles. Now, think of a situation where in 0 minutes you went 5 miles. I know it sounds weird, but what if you were doing like a relay race and your position was 5 miles into the race? Okay, at 0 minutes, you might have been at 5 miles. In this race, 0 minutes, we're at 0 miles. Then it says on page 131, what does 1, 1/10 mean? So see here I'm at 10, 1. If I was at 1 and 1/10, see how tiny that would be? What does that mean? Well, look at your X. This is X, and X is time. So that means 1 minute and Y, 1/10 of a mile. That's also called, please write this down and let's not forget this word. This is your unit rate. This is where your K comes from. Your K comes from what do you do with 1 when X is 1? Okay, when X is 1, what do? In this situation, we had X as 10. That's why we had to do some math here. Okay, let's look at number 3 on page 131. What if, okay, so suppose you drew a graph representing the relationship of 1/8 X. So pretend we're comparing someone's, because remember, this whole situation is Damon running. This is Damon. This is his running. And if we know how far if we know the time he ran, we could do the math. So this is Damon. Let's pretend we have another person who's running Y equals 1/8 X. That means he's running or she is running 1/8 of a mile in 1/8 of a mile in a minute, not 1/10 of a mile in a minute. So who's running faster? This guy or girl. And whose graph is steeper? This one, because it's actually a bigger number. Think about it. Would you rather have one piece of a pizza? Well, you have to like pizza to answer this question right. So assuming you like pizza, would you rather have one piece from a pizza that was divided into 10? Or would you rather have one piece of a pizza that was only divided into 8? Think of which one's bigger. The divided into 8 one. Everyone's getting bigger pieces. So that makes this bigger, which makes this graph steeper. Because instead of at 1/10, they're at 1/8, which is a little bit higher, which is going to make this graph become steeper. All right. And then we're going to do one more thing. I'm going to erase though, because we're going to come back to Damon and his equation. I don't want to get confused with whoever this person is who's running faster than Damon. Damon's competition. All right, so let's talk about Damon for a second. So Damon's situation, his equation, his line, okay, his everything is y equals 1/10 x. We go 1/10 of a mile in 1 minute. So we're going to use our equation now to decide how far, as long as he's constant, how far he runs in 40 minutes and how far he runs in, or how many minutes it takes him to do 7.5 miles. So what you have to do is when we want to use our equation, you got to know which one's x and y. This is x, this is y. Minutes was x, and miles was y. So when I want to find out 40 minutes, I got to plug in the 40 where the x is. And because 1/10 is being multiplied by x, I have to do 1/10 times 40. So I can cross cancel. So he can run in 40 minutes 4 miles. That's called plugging it in. Going, what is going on with these two things? Oh, they're being multiplied. I'm going to put x in and then multiply. Okay, and then you know how to do that. And then y equals, and y is your distance, so 4 miles in 40 minutes. Now we're going to plug in the 7.5 for y. So I'm going to put the 7.5 where the y is. Okay, so this is a little bit harder math to do. So I'm going to explain this, and then I promise you we'll do more problems like this in case it's a little confusing. If I want to multiply by something to both sides to get rid of my denominator, I can multiply by 10. Think of cross canceling, because these will cancel. And what's left? 1x. And isn't that always what I want? 1x. But if you do it to one side, you got to do it to the other. So multiply the other side by 10, and it's really 75. Don't forget what x is. X is minutes, so that means 75 minutes to go 7.5 miles, which you're never going to see me do because I can barely run 1 mile. Okay, but hopefully this makes sense. I know that times 10, it's kind of hard. This is kind of a little trick. I multiply by the denominator to get rid of the denominator. And then if I do it to one side, I do it to the other. You're going to see it more often. You might have another way to solve this, but this is the quickest way. And like I said, I'll show you these more often. I would like you to pause the video. I'd like you to go to page 131, and I'd like you to do the your turn. And when you turn the video back on, I'm just going to give you the answers. Okay, so pause. All right. Hopefully you did the problem because I'm running out of time and I got to read the answers quickly. Okay, so the graph that you were looking at shows the distance between, or the relationship between the distance a cyclist travels and the time in hours. Time is x. Distance in miles is y. So A, what does the point 4,60 represent? It represents that the cyclist rides 60 miles in 4 hours. B, what is the constant of proportionality? So you did y divided by x, and you got 15. C, write an equation, so it should say y equals 15x. I hope you got it right. I hope you're getting this. If you're struggling, just keep practicing. Email me, come to tutoring. You guys are going to be experts at this in no time, okay?